Here we're going to look at a couple of examples of calculating new capacitance values for situations where we are inserting dielectrics in between the capacitor and seeing how the dielectric inserted changes the overall capacitance. So to start all of these problems, assume you have a capacitor with nothing but vacuum in between. So with nothing but vacuum in between the parallel plate capacitor, we get C naught, kappa is of course 1, epsilon naught, A naught over D. Now when we insert the blue from the left side and the red from the right side, we get an equivalent situation shown over here, and this is important. This is your analysis circuit, so you definitely want to always redraw these circuits as an analysis circuit and do the calculation for the new capacitance based on this analysis circuit. The key feature that changed is the area in this case. So the blue now has half the original area. The red also has half the original area. So that's where this A naught on 2 comes from. So when we look at the capacitance C1, we get kappa epsilon naught A1 over D1. The A1 is A naught on 2, and then we're left with epsilon naught A naught D naught, which is our C naught. So we get a C1 value. I can squeeze it in up here, I think. We get a C1 value of 1/2, right? 1/2 kappa 1 C naught, and similarly we'll get a C2 of 1/2 kappa 2 C naught. So therefore, when we do the new capacitance, which new meaning after the insertion of the dielectrics, we get C1, right? C1 plus C2, which gives us the 1/2 factors out. We're left with kappa 1 plus kappa 2 C naught. So there you have it. So this is the type of problem we're looking to solve. And the second example I have here is the series connection. So I invite you to pause the video here. You can take a look at the beginning analysis, try to do the solution yourself, and when you unpause, we'll take a look at it together. Okay, so hopefully you have given this a try. We have our initial C naught circuit with just the capacitor plates, nothing in between, so that's the C sub 0, right? Kappa epsilon naught over D. Our analysis circuit then is the series connection, so hopefully that all makes sense. The key feature that's changing now is the distance. The D naught goes to a D naught on 2. The area of the plate remains the same for the red and the blue. So what we're left with in terms of our capacitance changing, we get a C1, right, equals kappa 1 epsilon naught A1 over D1. The A remains the same, so we get kappa 1 epsilon naught. A remains the same. We get a D naught on 2, so that gives us a 2 kappa 1 epsilon naught A naught over D naught, which is our 2 kappa 1 C naught. And we, of course, will get the same for the red. The C2 is 2 kappa 2 C naught. And we again have to be a little careful with our algebra now because we have 1 on C new equals 1 on C1 plus 1 on the C2. And I will not show the algebraic steps here, but hopefully we will agree that C new equals 2 C naught kappa 1 kappa 2 divided by kappa 1 plus kappa 2 when you get common denominators and rearrange the algebra. So there you have it. I'll scroll back down. You can pause the page to get this down. And of course, if you have questions, we should go over that in class.